Welcome to Hartman Math. Before we get into today's lesson, we're going to start with a warm-up. Kind of connects back to our previous lesson, finding the x and y intercepts of a function. Remember, our strategy was we wanted to find the x-intercept, set y to be 0, solve for x, and vice versa for finding the y-intercept. So go ahead and pause the video here. See what you can do as far as working it out. All right, to find the x-intercept, we're going to set y equal to 0. And one of our strategies would be to factor. Now, back from Math 3, possibly even Math 2, with 4 terms, factor by grouping was a strategy that you learned. So we're going to group this into the first 2 and the last 2 terms here. When we do that, we're essentially going to factor the first 2. We do that by factoring out a greatest common factor. And the second 2, also factoring out a greatest common factor. Real quick though, if this sign here in the middle is negative, this needs to be negative. Once we recognize that, in our 2 parts here, we have a common factor of x plus 1. That's our greatest common factor. We factor that out to the front, and then the leftovers become the other factor. So greatest common factor of x plus 1, remaining factor is x squared minus 4. And then this we could factor. That is a difference of squares, so we can factor that into x plus 2 and x minus 2. So setting these all equal to 0 is going to lead us to our x-intercepts, negative 1 comma 0, negative 2 comma 0, positive 2 comma 0. It does not matter the order that you list them. I have listed them from left to right as you would see them on the number line. The y-intercept, much easier. Set x to be 0, there, and there. And then we get 0 plus 0 minus 4, and we would get negative 4. Now, we weren't asked to graph this, but you could graph this on Desmos. Would be an easy way to graph this using that application, and then you could easily verify all of this information. Today we're looking at 1.3 linear equations in 2 variables. Basically means we're going to talk about equations of lines. It's something that goes all the way back to Math 1, even Math 8, possibly. So some things we're looking at in a y equals mx plus b format for a line where we intersect the y-axis at the y-intercept, that's 0 comma b. So whatever that is, like if that's 0 comma 5, 5 goes there. And then, so we've got positive slope if from left to right the line is going up, negative slope if from left to right we are going down. We're kind of always going to look at it from the left to right perspective. And the y equals mx plus b is considered to be slope-intercept form, where m designates the slope, b designates specifically the y-intercept. So that's all summarized here. Pretty easy to get a graph from there, with the exception of the line x equals a. So x equals any real number, like x equals 9 or something. That's going to be a vertical line, and it cannot be expressed in slope-intercept form. So if we see something like the equation x equals 3, we're just going to need to understand and know that's a vertical line, and then it passes through 3 on the x-axis. So kind of point there, draw the vertical line. Slope, as I say here, would be undefined in that case. All right, so we're going to sketch the graph of this line here. We first may want to get it into y equals mx plus b form, which means to isolate the y, get the y by itself. So we're going to leave this here. We're going to undo the minus 3x by adding 3x to both sides. Undo the plus 8 by subtracting 8 on both sides. Here we are That is the form we want to use, x's before constants there, because that does lead to the y equals mx plus b format. So now we got to get rid of the -2. We're going to divide both sides by -2. Division does distribute. So we're going to divide this by -2, and we're going to divide the -8 also by -2, which is where the positive 4 comes from. When we divide a positive by a negative, you just kind of want that negative sign to go out in front. Remember from what we looked at before, that's our slope, which means from left to right, it is going to be trending down. All right, our next step, we're going to start with the y-intercept. This is the b. We're going to plot that on the y-axis, definitely on the y-axis, 1, 2, 3, 4, up. There's our point. And then from there, slope, remember, we're always going to move from left to right. Negative means go down, down 3, right 2. So down 3, right 2. It's our second point. 2 points determines a line, so we can draw the line. You're doing this at home there with a straight edge, ruler, ID card, bank card, something to make it official. Put arrows at both ends, and we've sketched our graph. If we need to find the slope of the line, we've got a point here, a point there. We've got rise over run. So y2 minus y1, that's how we would find the rise. Take the y-coordinate of the second point, subtract the y-coordinate of the first point, divide by x2 minus x1, rise over run. And that essentially takes us down to the slope formula. Slope, usually we'd use the letter m to designate slope. Change in y over change in x, rise over run, and then there is by coordinates how we would do it. If we were just given the coordinates, that's the slope formula. So here it is again officially. As long as x1 does not equal x2, because that would take us back to our other exception, which is that vertical line. So it doesn't work for a vertical line, because you would get 0 as your denominator, and thou shalt not divide by 0. So we can now use that formula given 2 points to find the slope of a line. So that's our next task, example 2, find the slope of the line that passes through these 2 points. And as we're listing multiple points, you can, if it helps you, kind of label. Say that's my x-coordinate of the first point, y-coordinate of the first point, x-coordinate of the second point, y-coordinate of the second point. It really doesn't matter if you designate this one as point 1 and point 2 or vice versa. You would get the same answer in the end. So if we go straight into the formula, which is right there, y2 is the -6. Minus, and keep track of the minuses and the negatives. We're going to go minus 2. And then on the denominator, 2 minus -2. Not 2 minus 2, 2 minus -2. So if we evaluate, we get -8 divided by +4 for a final answer of -2. That is the slope of that line. We now want to write an equation that passes through 2 points. We might want to use the point slope form to do that, where this is another way we can kind of start our equation of the line. Y minus y1 is equal to m, as long as we know the slope, times x minus x1. So find the slope-intercept of the form of the equation that has this slope and passes through the point -2, 7. So the issue is that we do not know the b. So using y equals mx plus b would be tricky in that we do not know the b. But we do know just a generic point, a point, and the slope. So we can use that point-slope form. So this is x1, y1, y gets left alone, x gets left alone. We're going to substitute here, here, and here. y-coordinate of the first point is 7. The slope we were told is -3. x1 is -2. So simplify here. First, that becomes x plus 2. And then if we distribute the -3, -3 times x, -3x. Remember, this is a plus 2. -3 times positive 2 is -6. And our last step is to get the y all by itself, to get rid of that -7, add 7 to both sides. Final answer in slope-intercept form, in that y equals mx plus b form. Okay, checkpoint. You're given a point and another point. Find the equation of the line. It's an extension of the last example. First thing you notice is, I don't know the slope. I'd have to find the slope. So pause the video here, see if you can get the equation of the line that passes through those 2 points. As I was hinting at earlier, we don't know the slope, and that's going to be tremendously important. So we're going to go find the slope first. We're going to use the slope formula. First point, second point. So use that y2 minus y1 over x2 minus x1. So that's the first thing we would do. And we go through, we get -11 divided by 0. Well, I can't divide by 0. That makes the slope undefined. The problem is now we can't really use y equals mx plus b or anything because this is not a number. We can remember, oh, when the slope is undefined, that means the line is vertical. And if the line is vertical, it has that equation x equals whatever value that we think. Well, if we look at the points, we're talking about x equals, look at the x coordinate. It's 3. What about this one? It's 3. The x coordinate is always 3. So we do have our vertical line x equals 3 that passes through those 2 points. All right, our next look in studying lines here is in dealing with parallel and perpendicular lines. So starting with parallel in a coordinate plane, for parallel lines, their slopes will be equal. So if the slope of one of the lines is 2/3 and the slope of the other line, if they're parallel, also going to be 2/3. Perpendicular, the way their slopes are related is that they are negative, or we can think opposite reciprocals. So if one of them was 2/3, then for perpendicular, the other would be -3/2. One of them is positive, the other has to be negative, opposite reciprocals. So example number 4, we have this line here. We have a point that it's going to go through, and we've got 2 different problems, right? Equation of a line that's parallel to this one and passes through that point, and then a second problem perpendicular to it and goes through that point. Now our issue with our line here, because this is all about slope, we don't really yet know the slope. So one strategy for this is to find the slope of an existing equation. Let's get it into slope-intercept form. So we want to solve for the y. Let's get rid of the 3x. So we're going to subtract 3x on both sides. We have to get rid of the 2. We're going to divide by 2 on both sides. Remember that that does distribute over on the right side to divide both terms by the 2. And that would be our equation. Now, the only part about that equation that we care about is the slope, the m part, the part in front of the x, the coefficient of x. So we know here for our given line that the slope is -3/2. So if we start then on part A of our problem where we want to go parallel, the slope has to be equal. It has to be the same. So if this one's -3/2, our slope has to be -3/2. And here's our point, which is not a y-intercept. So we're going to use point slope form. So y minus y1 is equal to our same slope for parallel times x minus x1. And we are going to want to get this into slope-intercept form in the end, as that's what the direction said. So simplifying over here, we get y plus 2. We want to distribute here. We're going to get negative 3/2 x plus 3/2. And the last thing would be to subtract the 2. Now that does create a little bit of an issue over here, where we have to subtract 2 from 3/2. So we're going to need to create a common denominator to do that. So we can think of 2 being 4/2, 4 over 2. 4 divided by 2 is 2. So when we subtract 2, we're really subtracting 4/2, which is why our final answer here is y equals negative 3/2 x. If we subtract 4/2 from 3/2, we get negative 1/2. So the part B to this is now to do the perpendicular. We've already done some of the work already to identify for the given line the slope. Now for perpendicular, we won't want to keep the same slope. We want to make the 2 changes. Opposite, reciprocal. So opposite of negative, and then reciprocal of the fraction here. And if it's not a fraction, think of it as being over 1 and then flip it. So y minus y1 is equal to, now our slope is positive 2 over 3 for perpendicular. We can distribute that, 2/3 x minus 2/3. And once again, we have to subtract 2, but this time now we have over here negative 2/3. So we need to think of common denominator in terms of thirds. It happens to be that 6 divided by 3 is the same thing as 2. So we're going to be subtracting 6/3 on both sides. If we subtract 6/3 from negative 2/3, we're going to get negative 8/3 as a b value or y-intercept. So we've written in slope-intercept form. Example 6, using slope as rate of change. So we're given an equation, a kitchen appliance manufacturing company determines that the cost of producing X units of a blender is given by cost is equal to 25, probably in terms of dollars or something like that, times the number of units produced plus 3,500. The y-intercept tells you that the cost of producing 0 units is 3,500. So that's probably that's called a fixed cost. It might be setup of whatever you're using to produce or whatever that might be. That would be a fixed cost, a setup cost. The slope is the variable cost. So beyond that, each unit produced costs 25 units per unit to produce. So they're saying that's a marginal cost right there. So interpret y-intercept and slope. That's what we're kind of going through. Fixed cost, variable cost, right there. All right, so checkpoint, we're given the value in dollars of the golf cart at Chilton High School. Tiers after purchase given by the function. The value as a function of time of the golf cart is given by the function negative 400t plus 3,000. What is and what does the y-intercept mean? And the slope. So pause the video here and address the checkpoint. So our y-intercept of 0, 3,000, it's kind of the purchase price. It's the price that right away, so no time has elapsed, but that's the value of the cart, $3,000 purchase price. And then the slope says it goes down $400 per year. So that's essentially how the value depreciates. It drops by $400 per year for each year of use. That's how much less. So after 2 years, that would be $800 of loss. 800 less than 3,000 gives you 2,200. And obviously this does have some limitations, because if you think, well, what about 20 years later? If you did try plugging in a 20 into this, you'd have like negative value. So it's probably only good for a limited amount of time. And that's all for today. Catch you next time.